All right, now I'll go ahead and jump into it. So, name of the talk, I promise to help you understand asynchronicity in JavaScript. Keyword there being promises. So we're going to have a kind of a general overview as to how the asynchronicity works in the JavaScript environment, define some key terms, and we're going to look at some code examples to illustrate how to work with promises. So in more detail, JavaScript is synchronous and single-threaded. Take a look at what does that mean? What does asynchronicity mean? How does JavaScript deal with asynchronicity, which would be a review of the call stack and the event queue or loop, a quick review of callbacks, and then kind of the focus of the topic. We'll get into promises, some of the motivation, and just a brief history of promises. We'll introduce some of the concepts like the states of a promise, promise chains, and the whole thenable situation, how to catch errors in a promise chain, attach finally in a promise chain, use promise.reject to handle errors, promise.all, and then we'll just have a brief, quick snapshot of async await, which is kind of another step to improve that whole process. I think introduced in ES7 or ES8. I think I got it in the notes later. Okay, so let's just start with single-threaded and synchronous. That, just to kind of distill it down, just means everything is running one command at a time, one line of code at a time, in exact order that it appears in the code. So that being said, we move on to asynchronous. So asynchronous means more than one at a time. And when I was approaching JavaScript, in more detail a couple of years ago, that always kind of was a sticking point for me. Everybody told me it was synchronous and single-threaded, and then we have Ajax. So I was always confused as to how that, I just kind of pretended that I got it and went on from there. But really, that was some confusion. And one of the most important key points in this talk is to know that this image comes from Hop on Pop, a Dr. Seuss book. And in this scene, they're looking at some fish in a tree, and it says, fish in a tree? How can that be? Asynchronicity, how can that be? So the way it all works is we're going to focus on the browser side of things. There is also a parallel in the node side of things, but just for brevity, we'll stick with the browser. So the first thing you understand is that the JavaScript engine it is single-threaded. It is doing stuff synchronously, as we established, but it's only one small part of the browser engine, or maybe not a small part, but just one part of the browser engine. Meanwhile, the browser is doing other tasks in an asynchronous fashion, an asynchronous environment. So rendering, like painting CSS and whatnot, HTTP requests that fire off and come back with some results. And so this is all going on, but in the meanwhile, JavaScript in and of itself is in fact single-threaded. So when I came to start to understand that, then it began to make sense. So going one layer below that, we take a look at inside the JavaScript engine, we have something called the call stack. And we start in the global execution context. In the browser environment, that would be the window. As the window calls functions, they literally get stacked on this call stack. So we can call some function might call another function, and so on and so forth. And so these keep stacking on top of each other. And again, in a synchronous, single-threaded manner. However, all the while, other stuff can be happening. So somebody can click on something, an HTTP request can fire off as a result of one of these functions, and the result can come back. And that is all going on in what's known as the event queue, and I think it's called the event loop over in the node side of things. Very similar model. So these functions, they start to pop off the call stack as they resolve and complete. Come to completion, they start popping off. And so JavaScript, being the call stack there, it's now empty. It's only at that point that JavaScript can reach out and talk to the event queue and say, hey, I got nothing else going on. What do you have going on, event queue? And then event queue is going to be like, yeah, I've been hanging around here waiting. Okay, I got this HTTP request that's all ready to go. You got something to do with that? And then that can fire off the call stack again. And it kind of goes through the whole event queue. But the key point to remember is that JavaScript is, yes, synchronous and single-threaded, but it's operating in an asynchronous environment. And so whenever it gets a chance, it's going to check that event queue. And that's That's the relationship between synchronicity and asynchronicity. Which, by the way, none of the spell checkers like that word. It always marked asynchronicity with their red underline. So it had me thinking, am I spelling this wrong? And the way, more specifically, that this whole communication takes place is through the use of callbacks or promises, and then async await in the newest spec. This is another diagram that's from MDN. It kind of tells the same thing. So we've got the call stack. We've got the heap, which is kind of like this just general area in memory where we store data, like, for example, all of the variables that we create. So that they're in communication, the stack and the heap. But the key point is, once the stack is empty, it can then start to get involved with the event queue and start filling up the stack again. And once I started to understand that, then I was more at peace with this whole synchronous and asynchronous thing going on. All right, so I mentioned callbacks. That's the most common and traditional way of handling, going along with this environment that I just described. This is actually some Node code that I wrote, a few months ago, and I've got a lot of sections of it collapsed, for brevity's sake. But one of the main complaints about callbacks in general is just how it gets a little messy. This code is actually not too bad. I pat myself on the back a little bit for keeping it as tidy as I can to a certain extent. But it is a very common model in Node. We're passing in a callback. We check for error, kind of an error first mentality. And then it starts to get messy right here because now we're on this area over here, and here's another callback. Everything from this brace all the way down here is just one giant function. That's the callback function. And then we start going in here, we look at read data file, and then again, we have another callback function going on here, and so on and so forth. And this, I guess the technical term is the pyramid of doom. You can kind of see here, when we start doing this callback approach, and we start getting more and more complex, we end up with this really ugly thing going on down here, which is, kind of resembles stepping stones of a pyramid. So callback hell, pyramid of doom, those are some terms that are associated with it. Like I said, relatively speaking, this code isn't that bad. This is actually from the website, callbackhell.com. And if you're not that familiar with callbacks in general, this is a nice website that this is the first slide or first snippet they post up there. And it shows like a really kind of a bad example. And by the end of it, they do actually clean it up quite a bit by just making things more modular, and it's not as bad, but it still has this, weirdness at the bottom after it's all said and done. So, if you want to learn more about optimizing callbacks, you can check out that website. But here, same type of thing. We're doing, we're reading a directory, and then we're pulling in a bunch of files, and we're checking, it doesn't really matter too much. That's their code that they put as an example. But the key thing is, that's literally what they call it, callback hell. So, and this kept me away from JavaScript. Every time I had JavaScript, up until a couple of years ago, I was just source it out or get somebody else to do it for me, and I just worked on other stuff. But a couple of years ago, I finally was like, enough running from JavaScript, let me investigate this. So I came to understand the callback model. Then I started to come to realize that there's a better way, introduced in ES 2015, which was the big, shift in the whole JavaScript language, and definitely beefed it up quite a bit. And that brought us to promises. So at this point, we're going to just touch upon some of the key points on promises, and then we're going to actually look at some code involving promises. So promises were actually, even before ES 2015, I never used it, but there apparently was a jQuery.promise, and there was a prominent promise library known as Bluebird. And one thing I should mention also is that promises are not like a JavaScript invention or anything. Promises have been in computer science for quite a while. There was papers back in, I think, like the 80s talking about promises, maybe even before that, as a computer science concept. So promises are definitely not a new thing at all, but they were never really implemented as part of the JavaScript spec. So we had a Bluebird, we had jQuery.promise, and eventually it became standardized by what's known as the A+ specification. So the A+, just like all good things in code and whatnot, we have to kind of start to standardize things. So rather than all these different promise libraries popping up, there was a set of standards established known as the A+ specification. And the general gist of it, or the definition, is that it should be an object that represents the eventual result of some asynchronous operation. The key point to remember is it's not that the result itself. And so when I started learning promises from kind of a naive point of view, I had a hard time reconciling that, understanding that it's not really the result. The result is in there, but it's wrapped up in this promise object thing. So it's the key defining parameter of promises is that it needs to be thenable. Okay, so in other words, it has to have a then method, and we'll definitely see what that's all about in the real code. So essentially, it's a promise to resolve eventually. Either there's going to be some value, some usable positive result, or some reason why there will be no fulfillment. And that's what a promise essentially is. So I put some all cap, kind of like shouting these words here, kind of like the key terms that you'll hear if you're, learning about promises. So until there is a fulfillment or a rejection, the promise is considered pending, then a promise is settled. So those are the key terms you'll hear about. So a promise either is fulfilled or it's rejected, and until that point, it's pending. Once it's fulfilled or rejected, it's settled. Once settled, this is a very important thing to also understand, the promise state cannot change. You can't jump from fulfillment to rejection and vice versa. Oh, by the way, I think anybody wants to jump in with questions, just speak up. I know kind of keeping a conversational thing, and I've been kind of flying through these. So anybody has any questions at this point? Otherwise, I'll keep going. All right, so the promise state cannot change. That's one of the key points to understand when working with promises. And so this was I made a couple like silly models about that. So let's say a client talks to a server and it's using, like, for example, the fetch method, which is what we're going to focus on in the code example. The servers basically say, hey, you know what, I promise to resolve your request. That's, it's basically coming out and saying that. And when one of two things is going to happen. Hey, your object is resolved. I've sent you back a resolution. It's wrapped up in this promise object. Or, no, it didn't work out. I basically can say I broke the promise. Actually, I promised to resolve it, but it was rejected for some error. So in either case, your resolution or your error or your rejected reason gets wrapped up in this promise object. And at that point, the promise is considered settled. So that's a brief visualization of some of the concepts I just covered. And then one more analogy is when you go to a restaurant, you're expecting to get a table. And, sometimes you don't get, the result you want is a table. But sometimes instead of a table, you get one of these buzzer things. That buzzer, think of that as a promise. So you're handed the buzzer, and the expectation is you're going to get the result of a table eventually, at some point. That promise is going to resolve. And so that's another analogy that kind of came to mind. And, so after a certain point, it goes off, and that means you've received a resolution, and you get your table. And I suppose to go along with that analogy, I guess maybe while you're waiting, the restaurant loses power, or they run out of food or something like that, then it would be a failed promise. You would turn in your buzzer, it would be settled, but it would be rejected for the reason that they ran out of food or the power went out, whatever it is. So that's another analogy that came to mind, when it came to promises. So that is actually where we're going to stop with the slides at this point. And I'm going to escape out of this and start pulling up some code. So any questions while I transition over here?
So like you said, even if it's rejected, it can't be changed?
Exactly, yeah. You turn in that buzzer and it's over. That promise is settled. You have to fire off a new promise. You got to come back to the restaurant the next day or something and get a new buzzer. So yeah, you can't go back on it. That's exactly a key point. Very good.
Not just the status.
Right, exactly. Yeah, once it's settled, it's settled. There's no shifting, no changing, nothing like that. So there's no backtracking. It's pending, and then it's settled. That's it. Anything else? Okay. So for our examples here, I like to play around with the moviedb.org. It's kind of a fun way. It's a fun API. It's easy to get a key, and you can do all kinds of stuff with it with movies. In this case, this is just, it's not really that important what this is, but it's just a query that's going to give us back the most popular movies according to their database and so on and so forth. So we're going to be using the fetch API. Prior to fetch, we used to use, what is that, XML, HTTP request, or XHR, or whatever, and that was following a little bit more of a callback-oriented model. So fetch is one of the things, I believe was introduced in ES 2015, very handy, available in the browser. It's not part of Node. There's other things like Axios you can use in Node, but fetch, if you're in the browser, it's very easy to use, and that's why I'm using it here. So let's start with the most naive approach to promises, which is where I started. You know, I mean, that's just kind of how I guess I learn things. I just sit there and spin my wheels for a while. So this is how I was like, okay, I'm going to fetch this, and I'm going to get the results, and I'm going to log the results, and that's all good to go. But naturally, it's a very naive approach. If I do command, so I'm just going to have all the results here in the console, and that's where we're going to see everything. So when we simply take that naive approach, make that fetch request, we see that what we get back is a pending promise, and it looks promising, for lack of a better term. It does say resolved, and in here there's some stuff in the response value, so on and so forth. So that was where I started with promises, kind of just, okay, is this how it works? Clearly it's not, but I want to demonstrate that's what a promise object looks like. Just as we probably know in JavaScript, we can kind of open things up and dig into it as much as possible. So now let's fast forward the code just a little bit. And what I'm going to do is just copy that ID and then git checkout. All right, so now let's fast forward the code just a little bit. So so this is our introduction of then. So the first thing to understand when working with promises, again, to kind of get into that response, we want to call the then method. And this is what we talked about earlier. Kind of the core definition of promises is it has to be a thenable type of object. So if we grab our results and do then and just do a simple console.log, we get something a little bit more helpful. So let's Command R again. And so now we get, actually, it doesn't have to be that big. There we go. Okay, maybe like that. So now when we open this up, we actually are just looking at the response type. So that's a little bit better. That's a little bit more of what we're looking for. So let's keep going along this path here. Let's fast forward the code again, and let's demo the actual JSON in here. So copy the commit ID, git checkout, paste it. Okay. So in this example, we're actually looking at the JSON results. So this is what's happened with the code. We simply took the response and we're able to, I guess, for lack of a better term, JSONify it. So it looks a little bit better here. Now we see something like this. So now we can get a better idea of what we're looking at here. And this is getting very close to what we want. So we have, at this point, it's more of a feature of the, not IMDb, the movie database. It just so happens that they actually wrap that stuff in the results value, so we've got to tap into that. But you can kind of see what we're getting into, and these are currently the most popular movies that are playing. Right, so let's keep going along with that. We've just seen how to, yeah, yes. Oops. Yes, sir.
You say that the major results or the major data is in the results key.
Yeah, that's.
But in reality, if you wanted to use this API, you'd need the ancillary data based on page, and I suspect at the bottom there's probably number of pages. Yep.
Yeah, all of that there.
Results. So you would use that in order to show all the data you need.
Precisely, exactly. This is basically giving you, I guess, it defaults to like the top 20, and that gets wrapped up in the results. So most of the time when I'm playing around this, I'm trying to get titles and stuff, so most of the time I'm in there. But yeah, that's absolutely correct. All right, let's keep going. So now we're going to look at, let's actually grab this ID here. Fast forward the code just a little bit more. And oops, see the change in the code here. So that's all we're showing over here. Yeah, and I guess we're just taking it another layer deep. I was actually over here. So yeah, this is where we actually get into. So I'm just kind of showing you how you branch down into these results. And then finally, in the next one, we actually get down into the titles. Git checkout, oops. So yeah, we can actually now, we're actually going to start nesting the thens. Now, this is not the ideal way to do it because we're getting where we want to be. We actually did response.json, and that actually gave us, that actually brought back part of what we wanted. We have to attach another then, and then we can go into and do movie.results for each, and eventually get the movie title. So if we look back in our results, we are getting closer to what we want to see. And we get a list of the actual titles, which is what we were going for. So there's a lot of ways you can play around with the movie database. However, the problem with this is it's not really, you can imagine that if we had more stuff we want to drill down into, we're kind of going in the same direction as callback hell. We're starting to put these thens inside of each other. So like, what's the point? So yes, there is a better way to approach that, and we see that in the next commit. We're going to use a promise chain in this commit here. So let me copy that ID, git checkout. Oops. So now this is the code, how it should look a little bit cleaner as a promise chain. And this is where we start to see the benefit of using promises over nesting callbacks. So we can have all the thens that we want, and they're just going to stack on top of each other right here. So the results of this code is exactly the same. However, it is a little bit, cleaner. We still get the same results that we were expecting. So that is what's known as a promise chain, and you can keep stacking the thens over and over as much as you need to without doing any nesting. Ends up being a lot neater.
Something important to point out.
Yes.
Before we switch off of the code. The reason why this chain works the way it does, if you're not familiar with arrow functions, whenever you have a one-line arrow function, like up on line 6 where you see then response fat arrow and then response.json, that single line arrow function has an assumed return. So what you're doing, yeah, there we go. It's the same as saying return response.json. And because response.json returns a promise itself, then like the next link of the promise chain can jump into that and work off the promise. So just like if you're new to ES5, I know that, or like in arrow function and stuff like that, I know that can throw it.
Yeah, I'm glad you pointed that out. So yeah, absolutely, I should have put a comment in there about that. Yeah, this is the long way to write it. And yeah, when I teach, normally when I teach my classes on campus, yeah, I always try to show the long way, and then I say, hey, if you're comfortable with that, you can stick with that if you really want, but here's the shorter way. So I've got.
It's not necessarily the long way.
Sure.
If you have multiple lines of code, you have to do it this way.
Yes, exactly. If you just have one line of implicit return, yeah, if you just have one line though, yeah, you can shorten it up to that. So.
It's going to be that, like, you're only introducing another then, and you have something that returns another.
Exactly, yes, yes. So this return here sends another promise, and that kicks off the promise chain. Yes, sir.
Yeah, so I know the reason we put JSON is because we don't know what is the response type. It could be anything. So what if, like, I have some weird use case where I'm returning XML or HTML, for example. What do I, because I'm looking at MD and like I'm not sure which method to use for like something that's not JSON.
I would have to defer that to someone else. I guess I've always just worked with the JSON.
So the response object that's being returned here is part of the fetch API, and so you should be able to look at the fetch API and see which methods are available. If the data being returned from response.data is being formatted as JSON, if there isn't that, like I never work with XML, but I would imagine there's probably an XML method on there that either translates it or
Parses it somehow.
Yeah, and if there's not, you could always put, like, you could expand that function so that you get the curly braces, and then you could do like a type check on the response, and then return either JSON or XML or a string or something like that in that layer of the then clause.
Yeah, just I have some legacy code that I used to work with. I think I still work with those.
Yeah.
Uses like jQuery AJAX, and it returns the whole HTML page. And parse that and just do some like inner HTML kind of thing. So I was like, oh, actually I wouldn't know how to convert that like using response.
Yeah.
I'm looking at the MDN right
it's HTML, you can actually create a DOM,
Yeah.
virtual DOM object and iterate through it that way. XML,
And if you want to swing by after the presentation, I can give you a second pair of eyes.
Sure. Thank you.
Oh yeah, no problem. So yeah, promise. Oh, go ahead. Yeah.
So are we blocked here?
Say that again.
Are we blocked when we're calling then, or what's happening in the actual flow?
Sure. So when we go through the first then we're taking our initial response and, like I said, converting it to JSON or calling the JSON object, and then that's going to spit out our next promise, and then we connect that on our chain, and then we're resolving that afterwards. Is that?
I think it's back to the first diagram that you had of like the loop,
stack.
right? Yeah. The stack and loop.
Oh.
then get put on a stack separately.
Oh, I see what you're saying then. Yeah, every time you get back it's like the response.json, yes, that's going to go up onto the stack, and that's got to resolve and return its promise, and then we're going to put the other the stuff in the next part of the chain is going to go up on the stack afterwards. Is that?
Right after that movie results, the whole thing, you would see the console log before you saw any of a console log, say, from within the day.
Yeah, actually I think we can just go ahead and add that on here and check that out. So, yeah, if we do it like this, oops. Why am I getting oh, there we go. Okay, so if I do it like that and refresh, then we can see, yep, that's going to be at the top of the stack. So that's a very good example. Thank you for that. So, all right. So let me clear that off. Any other questions on the promise chain? Oops. So we saw that was kind of I said the longer way, but yeah, it is necessary to make those braces if you have multiple lines. With the case you have one line, we can do that. We can just do the implied return. So let's actually look at what happens if everything doesn't work out. Let's actually look at error handling. So I'm going to copy this over here. Git checkout. All right, so with the error handling, remember that only one thing can ever be called. So now, inside of our then, the then object, or I'm sorry, the then method can actually take two parameters. So you can notice there's a comma here. So there's a response handler. Optionally, we can pass in an error handler. Okay, so that's just one of the ways. It's not the best way. We're going to see a better way in just a little bit. But it's one of the ways we can handle an error in our console. So we have a question?
I was just saying, expect it to work.
Oh, yeah, expect it to, exactly. Oh, don't worry about it. So that's one thing to be aware of. So the then, if you looked up on the specification, and I guess these things kind of help here, but just know that the first argument is going to be the success, and the second argument is going to be the error or the fail or something bad is going to happen. So that's one way we can handle errors. Let's move on. Let's actually. Yeah.
I totally did not know that you could add an error as a second parameter.
Oh,
And
okay.
I've had what you're about to show.
Yes.
I've had checks at the end of for which kind of error it is, based on where the error is thrown within the chain. And I can totally see how being able to specify an error handler at a specific level and a global error handler would have made some of my code a lot easier.
Oh, okay.
So
Well,
I'm glad to see one.
I appreciate that. So, and yeah, that's actually a good point. I was actually just about to say, I don't really know why you would bother with this after I show you the next one, but I'm glad you said that because exactly, that's a great point. That's like local error handling, and then what I'm going to show you is the global error handling. So what we can do is come in here and just, we'll just make, I'm going to go in here and mess up my API. Just add, oh, I did not mean to do that, sorry. So, yeah, sorry. Okay, anyway, we'll move on from that. And let me hit R. And then right here we have, actually, let me go back here and show the code. So I added a console.error, and this is our, a custom error message. And we can see that in the browser, we see that spitting out right there. And then it's got the other feedback in there too. But that's one way to do, as he called it, a localization of an error. A lot of times, though, rather than having, because especially if you have the same error and you don't have custom error handling, that's going to be a bit tedious. Again, we're supposed to make it more convenient and cleaner. So we don't want to put that same error, copying and pasting it or whatever. So we're going to actually use something called a catch. And that's the, I guess you, like, I like this terminology, the global error handling. And so we will see, I'll just stash what's in there. Okay. And we come back and look at the code now. So we have, we're over here, rather than putting the error, passing it in as a second argument, I have one catch-all down the bottom. And that's probably a similar model to what folks are accustomed to seeing, kind of like a try-catch. It's not a try-catch, but it's, goes by the same name and kind of follows a general structure. So what ends up happening, if any of these things error out, any of these parts of the promise chain error out, then we're going to trigger this catch. Now, one thing, we're going to see how to handle this. One thing I wanted to point out, which is kind of a little bit of a devious error in a situation like this, what will happen is I can still get back a quote-unquote good response, but that response could be like a 404 or something like that. If I get back a 404 right there, it's not going to consider that. It's still a resolved promise. I still got back a result. And I'm not, and this error will not trigger if I get something back like a 404. So that's something to be aware of. You want to account for that in your code and know that, hopefully that makes sense. Like, you're still getting back a response. 404 is a successful response. So it will not trigger this error. So you want to handle those types of errors kind of individually and be aware of that. So any questions on that? Okay. So moving right along, we can also do finally. Finally, we can do finally. If we go back to our code here. So in this case, we can throw a finally anywhere you want. And as you may guess, finally is something that runs no matter what. Whether it's successful or an error, it's going to run no matter what. So I've put a note in here. The ES8 actually introduced finally. It will execute no matter what. It can be placed anywhere. Usually we would put it at the end. For example, if we were loading some results and maybe we had like a loading graphic or a spinner or something like that, you might want to clear that off, using a finally, for example, or any other like kind of boilerplate message. Yeah, go ahead.
I'm sorry, I noticed you have two.
Yeah, let me show you. Yes. So the reason why, that's actually exactly what I was. If I reload this, I just wanted to point out that the finallys will fire. So it's probably not realistic that you would ever have two, but I wanted to illustrate that the finally does not have to go at the end. You can place it anywhere else in your code. Now, if I do the error thing and I mess up my API key, we can observe what happens. So the finally triggers before the error. So if for some reason you wanted to introduce multiple finallys, kind of weird, but it can be done, and I wanted you to be aware of the error that it fires. So the finally will go, and then the error will catch, and then the other finally at the end will fire. So that's why. Again, maybe that's not a realistic situation, but that is something you can do with a finally. Actually, yeah, can you think of offhand of a use case? I was just throwing it in there just for the heck of it. So, if anybody has a use case, but.
So you can use it finally for like notifications. So if you have a UI that's doing some kind of a AJAX request out to the server, and you either get a successful response or an error response, regardless of which one you want to notify the user.
Sure,
so
yeah.
You're then can handle the successful one, like packing up the successful information. The catch can like console log out to the error, and then both of those can return the message that you want to go to the notification system, and then like whatever like info versus like error or something like that, and then the finally can say fire notification to user, and then it pops up on your screen.
Yeah, we're all set or whatever, so cool. Yeah, so finally is definitely a set. There are some other promises things in here, like race and things like that. I don't even really touch on as much. I'll mention them, but I'm trying to focus on stuff that I thought would be more useful in everyday, day-to-day situation. All right, so that's finally. Now we're going to look at promise.reject. And then after promise.reject, we're going to jump into a slide before we wrap up the remaining code. So let's look at using promise.reject. So remember how I said earlier about because we can get back a response, but that technically fulfills the promise, so it's not going to jump into the catch. So one way to handle that is to use promise.reject. So we can say, hey, I know you think you're successful because you got back a response, but I want to know if that response is okay or not. If it's not okay, then I don't want you going with the response.json. I want you to use promise.reject, using a new keyword to generate an error, and that's going to come down here and allow us to trigger the error, to actually catch that error. So that is one way to handle that, where you're still using the promise infrastructure. So you can use promise.reject to create custom error handling like that. If I wanted to, I think, oops, stop hitting that key. I can mess up my API, and I think we'll see that actually occur now. So yeah, so notice that I got a response, but it was a bad response, and that's what got triggered right here. So error bad response was triggered because I had an invalid API, so I think that's what, 401 unauthorized or something. So it was a bad response. If I didn't have that in here, in fact, let me just comment this out. What if I didn't have that in here, and then I ran with it? Then we would get other weird stuff going on. So we would just get like a generic cannot read property for each of undefined. So what's happening in that case is it's saying, oh, we're successful, let's come in here and grab the movies and results, and it's trying to call for each in here. So it's just kind of going on a path that we don't want to do. We want to shut that down and handle that error ourselves. So that is the value of using promise.reject to handle errors. So. Yeah, I think that's a good. Yeah, in fact, you could do a throw error, I suppose. That would be one way to handle it. But promise.reject kind of falls into the flow of our promise chain and using that catch. So that is promise.reject. Now I believe we're going to move into promise.all. So before we do that, I'm going to go back to a slide on that. Let's come back to our slides. And this is just taken straight from MDN. Promise.all, let me just introduce like why you would want promise.all. So you might have and I'm going to show you that, we might have a situation where you want to fire off not just like the popular movies, but you want to fire off to a couple different APIs. You're making multiple requests. Each one of those requests does not need the value of the previous one. So you want to run them in parallel, and that's where promise.all comes in. So promise.all method returns a single promise that resolves when all of the promises passed as an iterable have resolved. It rejects with the reason of the first promise that rejects. So promise.all, as we'll see, is an all or nothing affair. Every single fetch in this case, or every single promise that I pass into promise.all has to resolve properly. If any of them fail, there's no partial credit. You don't get some of the results, you just get a straight up error. So that's something to keep in mind when using promise.all. So assuming it resolves, the value will be an iterable with the results of each individual promise in the same order of what we passed into promise.all. So in other words, if I have a bunch of API calls or something, I want to be able to rely on, I don't care when they finish exactly, but at the end, when I get that promise back, they should be in the same order as what I fired off. So I need to be able to rely on that so I can sort through my values. So that's the other thing to be aware of with promise.all. So that's actually it for the slide part. So let's go back into the code. And that, I think maybe that'll become more clear once we start playing with promise.all here. So get checkout. I keep forgetting I changed stuff. So. All right, so this is the logging the promise.all to the screen. So we'll kind of go back to where we started, and I wanted to illustrate just what happens. Well, this is how it looks. So fetch, in this case, we're doing a fetch for the most popular movies and movies currently in theaters and most popular movies back in 2009, 10 years ago. So we want to do that in parallel, because technically we could still pull that off and just do a then chain and all that type of stuff, but that's kind of silly, right? Let's get this off in parallel and do it all more efficiently. So when we do promise.all, we, in this case, we're going to pass in an array, and there's 3 elements in the array. You can see separated by the commas right there, 3 fetch requests. So we're basically, oh, not basically, we are passing in 3 promises to promise.all. Because remember that each one of those fetches is going to send back a promise. So promise.all takes an iterable of promises, as we just saw in the definition. So if we log that, we straight up just log it like we did before, we're back in a similar situation where we see something resolved. We have a promise value, which is an array. And that's what I said. You're going to get back, assuming that they resolve properly, you're going to get back an array, and it's going to have 3 promises because we passed in 3, and they're going to be in the same order as we wanted. So this is just to kind of shore up on what we just read, but let's, of course, make this more useful. So let's check this one out. We're promise.all with the response value. Okay, and let's see what happened with our code now. And so you're going to start to see a similar pattern over here, where we have we have response. We're resolving each one of those. It all comes back into this one promise, which I called movie results, and we're going to use the then method here. Let's log that and see if we've got anything more useful now. So now we've got this object in here, and we're starting to see those results that we want. I'm sorry, we have an array of objects in here, and we're starting to see the results that we want. There's that length of 3, and in here, if we were to keep digging, we would start to see some of those titles we were looking for. So let's keep going with that. Let's keep drilling down and see if we can get those titles to come to light. So here in the next example, we actually do log all of the titles. Git checkout. There we go. So in this example here, we get back that one promise, and remember that promise is an array. So then we take that and we can iterate over it with for each again. And of course, there's other we can do map and other things, but I like for each, especially when explaining things, because to me it's more intuitive. So we can do for each, and the similar type of thing as we saw before. Jump into the results for each of those, grab the movie, and output the title. So that's kind of the pattern. Still very clean, very clear. Can you imagine how this might look in a callback situation? We're definitely going to start getting all those multiple weird layers and things like that. It's going to be a lot harder to reason about. But once we, yeah, go ahead. Yeah.
So you're passing in all these in the array itself. You could store each promise in a variable.
Yes.
Or even have them someplace else.
Yeah.
Import them, and then just pass in the variable names in your all, right?
Absolutely, yeah. That would actually be a cleaner way to do it. Usually for demonstration, I just try to make everything blatant, just so it's really clear. But yeah, I could go up here and create a few more lines, put all these, and it would look a little bit cleaner. One thing I want to point out though, is notice that in here, in this situation, I went ahead and each individual promise, I'm going ahead and doing the then operation right then and there, if you will. Because if you don't do it that way, it starts to get harder to reason about. Essentially, you end up with an array of promises that you've then got to jump into and iterate, and then those, and it gets really complicated. So I would advise to go ahead and resolve your promise. And by the way, I have cleared out the error handling here just for demonstration. We're going to bring that back in just a little bit. But I would advise that once you get those in, each individual one, you should go ahead and resolve those as much as possible, just to make, that's how I would code it up at least. So, but you don't have to do that. All right. So in the next one, let's bring back the error handling. Copy. Okay, oops. Bring back the error handling. And this is what it looks like with error handling. And to Matt's earlier point, yeah, at this point, that's why I put a to-do in here. You would probably create a helper function to avoid all this repetitive code. But again, I like to explicitly show everything that's happening for demonstration. So in each one of these, we're doing the exact same thing. Obviously, we have some copy and paste code. And again, we would normally do a helper function. But I mean, nothing earth-shattering has happened here. You're still kind of doing the same exact thing. I just wanted to show that that initial promise that we had, it's just getting thrown into the promise.all array as as one of the elements in this array. And everything else from there kind of works out the same way. We brought back our catch down here, and finally, and all of that. So if I was to break one of these, again, let me come in here, and let me just break the last one. Let me give that a bad key, and let's refresh our results. And then right there, the other two presumably worked out just fine, but since one of them didn't work, it was 401, everything was canceled, and we got a bad response. But our finally, of course, still worked, finally all done. So that goes back to the point I brought up earlier, where if any of these fail, the whole thing fails. It's promise.all is an all or nothing type of deal. So this is more of kind of the complete picture here with using the promises that we started with, doing multiple requests in parallel, and then, like I said, when it's all working fine and good, we get some weird stuff. And so, of course, at that point, you have a big, long list. Everything's just thrown in one list. You can sort it, do whatever you want. So apparently Bumblebee is really popular, and these are some of those 2009 movies, most of which I've never heard of, Attack of the Gnome, whatever else. Okay, let me see. That brought, yeah, that's actually, yeah, promise.all, error handling. And yeah, that was basically the last commit there. So that brings us to the end of the promise. And then the last thing I'm going to show is I'm going to pull up async await. So any questions before I take this off?
So in this example, when you do multiple promises in parallel, will it cancel the other promises if one fails, or does it cancel those immediately if one fails? Or do the others have a chance to fail too?
Actually, you know what? I was just thinking about that this morning. I believe, actually, I'm going to defer that to anyone else they want to jump in. But I believe that it's like an all or nothing. So as one fails, there's no point in getting the rest of it.
You said that those three requests are going to parallel. The first one that fails, right, causes your promise.all to fail, and that's what you can see the error about. But the other two will still go through their cycle. They may fail or they may succeed.
We'll never know. Yeah, that is actually a good question.
It doesn't wait for everything else to fail.
Yeah, it just stops.
It just stops after the first fail.
And you can prove and disprove that in the network tab, because each one of those requests will create an entry in the network
That's
tab
true. Let's do that.
of the dev tools. And you'll see successful responses come back from them. It just doesn't get consolidated into the promise. Going on the assumption that we're
Overall, let's see. Oh, that's because they are all. Stop doing that. Gosh. Okay, overall. There we go. So yeah, actually, I should have thought of that myself. So yeah, thank you for that. So these two came back with, they resolved to 200, and there's our 401. But yeah, aside from the network tab, we'll never know if they did or not. So. Oh yes. Yeah, you will need a polyfill for IE11. Yeah, luckily I don't have to support IE11 a lot, but yeah, fetch is such a cool, common thing that yeah, you're not restricted to the XHR or whatever. You can definitely do a polyfill, and you know I would suggest MDN fetch, and usually at the bottom they have all those polyfill links there. So yeah, absolutely.
Even if polyfill isn't an option for some reason, libraries like Axios.
Yeah, or even Bluebird. Bluebird is specifically dedicated for. Oh, I'm sorry. You're talking specifically for fetching. Yes, Axios for that. Bluebird is if you wanted to polyfill promises, you can use that library, and of course jQuery. And because they all follow that A+ certification, you'll still get the same predictable results we've seen. Like kind of, it was based on a tutorial from a site called Level Up Tuts, run by Scott Polinsky, and I made my own version of something he had on there. And this was when he was using the movie database. This was part of a view thing or whatever, but I figured, well, I'll just show this here where we actually did it that way. And this is what, let me clear this sidebar here. And this is what, oops, no, don't delete anything. This is what it would look like using await, async await. So, you know, don't worry about the rest of this. It's like the view stuff. But in here, this is what we're working with to do our fetch data. So the first thing you want to do is let JavaScript know that, hey, this is something that's going to run asynchronously. And then inside of there, we can use a try catch, similar to what we saw earlier, where this will take care of any errors that pop up. And then meanwhile, when we've declared that this is async, we simply throw a keyword await in here, and then that's letting JavaScript know, well, literally to await those results. When you have something to assign back to results, then you can move on after that. So async await is, I guess, the newest way to handle this type of situation. It definitely doesn't fully replace promises, and just like promises don't necessarily fully replace callbacks. But being familiar with these approaches definitely opens up your JavaScript arsenal to go much beyond callbacks, and using things like fetch and Axios will return those promises. You know how to handle that, and you can actually do it with an async. So just know that if it returns a promise, then you can use async await like we've seen here. It's still using fetch and all the stuff that we saw in promises.
Yeah, it's okay to point out with async await is that it definitely doesn't replace promises, because
Right.
under the hood, async await is using promises.
Yeah, in fact, some might say it's syntactic sugar for promises, really. So,
It very much is.
yeah, it's not even necessarily adding anything. It's just syntactic sugar overall. So.
When you write down async, it turns that function, the function following it, into a promise. So if you do like async function, just print that out to the console or pause the debugger and look at it, you will be seeing a promise. So same with the await. Like the focus of it is to try to make the code read more synchronous, like you would.
Yeah.
Like with code is just like firing line by line, and then pausing whenever you're doing the fetch here. So like you'll stop on, like the code will fire, or at least the code will air quote fire down each of those lines, and when it hits line 27, it won't execute the rest of the code until the await has resolved that promise, and then from there it will either go down to line 20 or line 30, or it'll jump over to catch, which under the hood is the fail, or I guess under the hood is the promise catch.
Right.
Makes it more procedural.
Yeah, that's the main point. It's easier to reason about. I mean, to me, promises aren't bad to reason about, but yeah, you could shorten up some code, make it sweeter, syntactic sugar, by using async await, but it's definitely not necessary. But that's what.
Personally, I think it's less obvious.
Really? Well, that's just because of all the benefits of listening to my talk. So now you're all about promises. So. But I know that's pretty much all I had. So in summary or whatever, I hope that this was beneficial as a review of how synchronicity and asynchronicity works in JavaScript, at least within the scope of the browser. I hope you can see the benefit of taking something like callback hell and writing it out as promises. We looked at a promise chain. We understood that then is a key factor of using promises. We looked at a couple of analogies, and you were introduced to using fetch, and very, very fun to work with the movie database thing, just to play around and learn stuff. So, definitely encourage you to get an API key for that and practice stuff. And we saw that how we can handle errors, how we can run finally, and then we learned how to send multiple requests in parallel, and we wrapped up with async await, and I think that's all I have.